In this video, we're going to talk about how to find the derivative of a function. And so we're going to go over some basic differentiation rules that you need to know. The first one is the power rule. The derivative of x raised to the n is going to be n times x raised to the n minus 1. So based on that formula, what is the derivative of x to the second power? In this case, n is 2. So it's going to be 2x raised to the 2 minus 1, or 2x to the first power. And so that's the answer for the first example. Based on that, try these two. Determine the derivative of x cubed and x raised to the fourth power. So in this case, n is 3. So it's going to be 3x to the 3 minus 1, or 3x squared. Now for the next example, n is 4. So it's going to be 4x raised to the 4 minus 1, or 4x cubed. And so that's how you could use the power rule to find the derivative of a function. Now what about this one? What is the derivative of x? Go ahead and try that example. So this is basically x raised to the first power. So thus n is 1. So it's going to be 1x to the 1 minus 1, which is 1x to the 0. Anything raised to the 0 power is 1. So we just get 1. Now what about like the derivative of 5x? What's going to be the answer now? If you have a constant in front of the variable, you can move the constant to the front. So this is the same as 5 times the derivative of x. And the derivative of x is 1, so 5 times 1 will give us 5. The derivative of, let's say, negative 7x is simply negative 7. Now what about the derivative of a constant? The derivative of any constant is 0. Now one way that you can remember that is you can write 8 as 8 times x to the 0, because x to the 0 is 1. And so these two, they're the same. So this is 8 times the derivative of x raised to the 0, and using the power rule, it's going to be 0x raised to the 0 minus 1. And 0 times anything is 0. So the whole thing is just going to be 0. So make sure you remember that. The derivative of any constant is always equal to 0. Here's another one. Find the derivative of 9x to the fourth and also 7x to the fifth power. So this is going to be 9 times the derivative of x to the fourth, which is 4x raised to the 4 minus 1, or 4x cubed. And then you just got to multiply 9 times 4. So the answer is going to be 36x to the third power. For the next one, it's going to be 7 times the derivative of x to the fifth, which is 5x to the fourth power. And then 7 times 5, that's 35. So you get 35x raised to the fourth power. Now what about the derivative of, let's say, a polynomial function? 4x to the fifth plus 7x cubed minus 9x plus 5. Go ahead and try that. So the derivative of x to the fifth is going to be 5x to the fourth power. The derivative of x cubed is 3x squared. And the derivative of x is 1. The derivative of a constant is 0. So 4 times 5 is 20. 7 times 3 is 21. And this is going to be it. So it's 20x to the fourth plus 21x squared minus 9. So you just have to differentiate each term separately. Now what about this one? What is the derivative of the square root of x? Go ahead and try that. For this example, we need to rewrite it. This is x raised to the first power, but within a square root symbol, and the index number is a 2 if you don't see a number there. And so the way you rewrite it is like this. It's going to be x to the 1/2. Now we can use the power rule. So it's 1/2 times x raised to the 1/2 minus 1. 1/2 minus 1 is the same as 1 over 2 minus 2 over 2. 2 divided by 2 is the same as 1. And so this becomes negative 1/2. So we get 1/2 x raised to the minus 1/2. Now, whenever you have a negative exponent, you need to move the variable to the bottom of the fraction. So we're going to put x in the denominator of the fraction. So the exponent will change from negative 1/2 to positive 1/2. And recall that x to the 1/2 is the same as the square root of x. So at this point, we can replace x to the 1/2 with the square root of x. And so this is the first derivative of that function, the square root of x function. Let's try another radical function. Let's use the 7th root of x to the 4th power. So the first thing we need to do is rewrite it. This is going to be x raised to the 4 over 7. And now we could use the power rule. So it's 4 over 7 times x raised to the 4 over 7 minus 1. So 4 over 7 minus 1 is the same as 4 over 7 minus 7 over 7, which will be negative 3 over 7. And so this is going to be 4 over 7 x raised to the negative 3 over 7. So once again, we have a negative exponent, which means we need to move the variable to the bottom of the fraction. So the 4 is going to be on top, the 7 is going to be on the bottom with the x variable, and we're going to change the negative exponent to a positive exponent. And then at this point, we can turn it back into its radical form. So it's 4 over 7 times the 7th root of x cubed. Now, if you want to, you can rationalize the denominator, but I'm not going to worry about that in this example. So I'm going to leave the answer like this. And so that's how you could find the derivative of a radical function. Now, what about the derivative of a rational function, like this one? What is the derivative of 1 divided by x raised to the 5th power? So once again, we need to rewrite it before we could use the power rule. So what we're going to do is we're going to take the x variable and move it to the top. And as you do so, the exponent will change sign. It's going to flip from positive 5 to negative 5. So now we could use the power rule. N is negative 5. So it's going to be negative 5 times x raised to the negative 5 minus 1, which is negative 5x to the negative 6. So this is the answer, but we want to rewrite it. Since we have a negative exponent, we're going to move the x variable back to the bottom. So the final answer is going to be negative 5 over x to the 6th power. And so that's how you could find the derivative of a rational function. Now let's talk about the derivative of trigonometric functions. So here are some notes that you need to take down. The derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. Next, you need to know the derivative of tangent x, and that's going to be secant squared. Now, what do you think the derivative of cotangent x is equal to? It's going to be negative cosecant squared. Now, the derivative of secant x is secant x tangent x. Based on that, what do you think the derivative of cosecant x is going to be? This is going to be negative cosecant x times cotangent x. And notice this pattern. So anytime you have a trig function that starts with a c, notice that in the derivative they all have a negative sign. So that can help you to remember the derivative of the 6 trigonometric functions. So if you know the derivative of sine, tangent, and secant, you can easily find the derivative of cosine, cotangent, cosecant. Looking at the similar relationships between what you see on the left side and what you see on the right side. Now what about this one? Find the derivative of 5 sine x minus 7 tangent x plus 4 cosecant x. So all we need to do is differentiate each one separately. The derivative of 5 sine x is going to be 5 times the derivative of sine x, which is cosine x. Now once you differentiate sine, next we need to differentiate tangent. The derivative of negative 7 tan x is going to be negative 7 times secant squared, since that's the derivative of tangent. And the derivative of cosecant, we said it's negative cosecant cotangent. And so this is the answer. 5 cosine x minus 7 secant squared x minus 4 cosecant x cotangent x. So that's how you could find the derivative of trigonometric functions. Now let's talk about the derivatives of exponential functions involving the base e. Here's a formula that you're going to find useful. The derivative of e to the u, where u is a function of x, is e to the u times u prime. So for instance, let's say if we want to find the derivative of e to the x, it's going to be e to the x, so u is x, times the derivative of x, which is 1. So the answer is just e to the x. Based on that, what is the derivative of e to the 7x? Go ahead and try that. So it's going to be e to the 7x times the derivative of 7x, which is 7. So it's 7e to the 7x. Let's work on some more examples. Try these 3 examples. So using this formula, find the derivative of e raised to the 4x plus 3 and the derivative of e to the x squared, and also the derivative of 5e to the x cubed. So for the first one, it's going to be the same thing, e to the 4x plus 3, and then times the derivative of 4x plus 3, which is just 4. So it's 4e to the 4x plus 3. Now for the second one, it's going to be the same thing, e to the x squared times the derivative of x squared, which is 2x. And so it's 2x e to the x squared. And for the last one, it's going to be what we started with, times the derivative of x cubed, which is 3x squared. And so we could multiply 5 and 3, and that's going to give us 15x squared e to the x cubed. And so now you know how to find the derivative of exponential functions with the base e. Next, let's talk about finding the derivative of logarithmic functions, particularly the natural log function. The derivative of ln u, where u is once again a function of x, is u prime divided by u. So let's say if we want to find the derivative of ln x. So in this case, u is x, u prime, the derivative of x is 1. So u prime is 1, u is x, so the answer is just 1 over x. Let's try another example. Let's find the derivative of the natural log of x squared plus 5. So u that's the stuff inside the natural log. That's x squared plus 5. U prime, the derivative of x squared plus 5 is just 2x. So it's going to be u prime divided by u. And so the answer is 2x over x squared plus 5. For the sake of practice, try this one. Find the derivative of 3 times the natural log of 5x plus 4. So u, the u variable is going to be 5x plus 4, and u prime is the derivative of 5x plus 4. The derivative of 5x is 5, and the derivative of the constant 4 is 0. So it's just 5. Now we do have a constant in front of the natural log, so we're going to rewrite that here. So it's going to be 3 times this thing, u prime, which is 5, divided by u, which is 5x plus 4. So now we can multiply 3 times 5, and that's going to be 15. So the answer is 15 over 5x plus 4. So now you know how to find the derivative of natural logarithmic functions. Now for those of you who want more example problems on not just natural logs but logarithmic functions, exponential functions, and other things like implicit differentiation and things like that, check out the links in the description section below, and I'm going to post more video resources that can help you with derivatives. Now, the next thing we need to talk about is the product rule. The best time to use the product rule is when you have two things multiplied to each other. Let's say u and v. So what you need to do is you need to differentiate one of these two functions. So if you differentiate u first, leave the other one alone. And then it's going to be plus. We're going to leave the first function the way it is and differentiate the second one. So the derivative of u times v is going to be u prime v plus uv prime. I need to draw the u better. So this is a u, that's a v. Now let's work on some examples. What is the derivative of x squared times sine x? So in this case, u is x squared, which means u prime is 2x. V is going to be sine x. So v prime is cosine x. So it's going to be u prime times v plus u times v prime, which is cosine. And so this is the answer, 2x sine x plus x squared cosine x. Now let's try another one. What is the derivative of x cubed ln x? So in this case, we're going to say v is ln and u is x cubed. So let's write that. U is x cubed, v is ln x. U prime, the derivative of x cubed is going to be 3x squared, and v prime, the derivative of ln x is going to be 1 over x. So it's u prime v, 3x squared times ln x plus uv prime, x cubed times 1 over x. Now we could simplify x cubed times 1 over x. That's the same as x cubed divided by x, which is just x squared. So this is the answer, Now, if you want to, you can factor out the GCF. You can take out x squared, and it's going to leave you with 3 ln x plus 1. So you can write your answer like this. And so that's how you could use the product rule to differentiate certain functions. Now there's also the quotient rule and the chain rule, but I'm not going to go over that in this video. Instead, I'm going to post some links to some other videos where I cover those topics. So feel free to take a look at that when you get a chance. And don't forget to subscribe to this channel. Thanks again for watching.